In this next set of videos, I'd like to tell you about recommender systems. There were two reasons, I had two motivations for why I wanted to talk about recommender systems. The first is just that it's an important application of machine learning. Over the last few years, occasionally I visit different technology companies here in Silicon Valley, and I often talk to people working on machine learning applications there. And sort of ask people, what are your most important applications of machine learning, or what are the machine learning applications that you would most like to get an improvement in the performance of? And one of the most frequent answers I heard was that there are many groups out in Silicon Valley now trying to build better recommender systems. So if you think about what the websites of like Amazon or what Netflix or what eBay or what iTunes Genius made by Apple does, there are many websites or systems that try to recommend new products to you. So Amazon recommends new books to you, Netflix tries to recommend new movies to you, and so on. And these sorts of recommender systems that look at what books you may have purchased in the past or what movies you've rated in the past, but these sorts of systems that are responsible for today a substantial fraction of Amazon's revenue. And for a company like Netflix, the recommendations that they make to the users is also responsible for a substantial fraction of the movies watched by the users. And so an improvement in the performance of a recommender system can have a substantial and immediate impact on the bottom line of many of these companies. Recommender systems is kind of a funny problem. Within academic machine learning, so that if you go to an academic machine learning conference, the problem of recommender systems actually receives relatively little attention, or at least it's sort of a smallish fraction of what goes on within academia. But if you look at what's happening in many technology companies, the ability to build these systems seems to be a high priority for many companies. And that's one of the reasons why I want to talk about it in this class. The second reason that I want to talk about recommender systems is that as we approach the last few sets of videos of this class, I wanted to talk about a few of the big ideas in machine learning and share with you, some of the big ideas in machine learning. And we've already seen in this class that features are important for machine learning, and the features you choose will have a big effect on the performance of your learning algorithm. So there's this big idea in machine learning, which is that for some problems, maybe not all problems, but some problems, there are algorithms that can try to automatically learn a good set of features for you. So rather than trying to hand design or hand code the features, which is mostly what I'm doing so far, there are a few settings where you might be able to have an algorithm just learn what features to use. And recommender systems is just one example of that sort of setting. There are many others, but in going through recommender systems, we'll be able to go a little bit into this idea of learning the features, and you'll be able to see at least one example of this, I think, big idea in machine learning as well. So, without further ado, let's get started and talk about the recommender system problem formulation. As my running example, I'm going to use the problem of predicting movie ratings. So here's a problem. Imagine that you're a website or a company that sells or rents out movies or what have you. And so, Amazon and Netflix and I think iTunes are all examples of companies that do this. And let's say you let your users rate different movies using a 1 to 5 star rating. So using something 1, 2, 3, 4, or 5 stars. In order to make this example just a little bit nicer, I'm going to allow 0 to 5 stars as well, because that just makes some of the math come out nicer. Although most of these websites use a 1 to 5 star scale. So here I have 5 movies. Love at Last, Romance Forever, Cute Puppies of Love, Non-Stop Car Chases, and Swords vs. Karate. And we have 4 users, which calling Alice, Bob, Carol, and Dave with initials A, B, C, and D. We'll call them users 1, 2, 3, and 4. So let's say Alice really likes Love at Last and rates that 5 stars. Really likes Romance Forever, rates at 5 stars. She did not watch Cute Puppies of Love, but did not rate it, so we don't have a rating for that. And Alice really did not like Non-Stop Car Chases or Swords vs. Karate. And different user, Bob, user 2, maybe rates a different set of movies. Maybe he likes Love at Last, did not watch Romance Forever, gives that a rating of 4, a 0, a 0. And maybe our third user rates the 0, did not watch that one, 0, 5, 5. And let's just fill in some of the numbers. Okay? And so just to introduce a bit of notation, this notation we'll be using throughout, I'm going to use NU to denote the number of users. So in this example, NU will be equal to 4. So the U subscript stands for users. And NM I'm going to use to denote the number of movies. So here I have 5 movies, so NM equals 5. And for this example, I have loosely 3 maybe romantic comedy movies, and 2 action movies. And if you look at this small example, it looks like Alice and Bob are giving high ratings to these romantic comedies or movies about love, and giving very low ratings about the action movies. And for Carol and Dave is the opposite, right? Carol and Dave, users 3 and 4, really like the action movies and give them high ratings, but don't like the romance and love type movies as much. Specifically, in the recommender system problem, we are given the following data. Our data comprises the following. We have these values Rij, and Rij is 1 if user J has rated movie I. So our users rate only some of the movies, and so we don't have ratings for those movies. And whenever Rij is equal to 1, whenever user J has rated movie I, we also get this number Yij, which is the rating given by user J to movie I. And so Yij will be a number from 0 up to 5, depending on the star rating, 0 to 5 stars that the user gave that particular movie. So the recommender system problem is, given this data set, that is, given these Rijs and the Yijs, to look through your data and look at all the movie ratings that are missing, and to try to predict what these values of the question mark should be. In this particular example, I have a very small number of movies and a very small number of users, and so most users have rated most movies, but in the realistic setting, each of your users may have rated only a minuscule fraction of your movies. But looking at this data, if Alice and Bob both like the romantic movies, maybe we think that Alice would have given this a 5, maybe we think Bob would have given this a 4.5 or some high value, whereas we think maybe Carol and Dave would have given these very low ratings. And Dave, well, if Dave really likes action movies, maybe he would have given Swords and Karate a 4 rating or maybe a 5 rating. Okay, and so our job in developing a recommender system is to come up with a learning algorithm that can automatically fill in these missing values for us, so that we can look at, say, the movies that the user has not yet watched and recommend new movies to that user to watch, or try to predict what else might be interesting to a user. So that's the formalism of the recommender system problem. In the next video, we'll start to develop a learning algorithm to address this problem.